Hello, welcome to Developer. Just a few introductory slides first. Please be aware of others. We have a code of conduct. Basically, just be a good delegate, good attendee. There are people around if you need help. There's various people you'll be able to call on and ask. Please consider going and donating to the National Museum of Computing. These guys have helped fund this today, and they rely on donations from people like you and I and various computer using public to keep their operations running. Quick thanks to the other sponsors: Microsoft, Sage, Black Marble, Grey Matter, NDC, University of Hull, IO, Landmark. None of this would be possible without these guys, so please give them a tweet or two. Make sure that they know and they appreciate their help in putting on these events. Please do tweet about your session. Use the hashtag DDD2020 and tweet it to mention @Developer Day, and we'll retweet it and we'll mix it with all the others and we'll advertise your experiences. Right, let me just switch slides over and we'll get kicked off with this one. Right. For the next 45 minutes, I'm going to give you a small whirlwind tour of Microsoft's new proxying tool, Yarp. Now, the astute amongst you will have noticed that, yes, it is an acronym. It's yet another reverse proxy, and you'll see why that's apt as we go through the presentation. Quick introduction to me. I've been doing this game for far too long. So yes, I'm probably a bit of a grey beard by now, and if you do Microsoft development, you've probably come across me somewhere before now. If you want to stalk me, there's my socials. Drop me a tweet, drop me an email, tell me what you think. This is a new presentation. I haven't had time to practice it, so it might be a little bit rough and ready around the edges. So please go gentle on it. Okay, before we delve into Yarp itself, I just want to run through a quick refresher on what a proxy is for and why we might need one. Now, if you already know about networking and stuff like this, I do apologize, but a lot of developers don't actually look into this kind of the subject of this technology. So we're going to just go over it quickly and make sure that we all understand where Yarp comes from and why it's needed. Proxy server is a bit like a gateway between two networks. Unlike a router, however, it's not designed to route general traffic between subnets nodes. It's a bit more specialist than that. Proxy servers typically are used to provide a layer of security by hiding internal network points from systems on the other side of the proxy. A router, on the other hand, will rewrite addresses passing through it, whereas a proxy will actually terminate the connection, and that's a very big difference that a lot of people don't really understand when it comes to dealing with proxy servers. Proxy servers, when they connect to a downstream or upstream client, they are the source of truth. The address of the proxy server is the terminating address of whichever client or external system is talking to it. In terms of the OSI layer diagram, proxy connections are usually up near the top of the networking stack, tend to be around the application presentation layer, and they are definitely application and data orientated. Routers are usually lower down the stack, packets, frames, bits, down near the transport and the network layers. There are different types of proxy. The two main variations are your forward proxy. Now, a forward proxy will terminate connections from internal machines connecting to outside connections, making them all appear as one single address to the outside world. Normally, a forwarding proxy is used to provide security to a corporate network in so much that it filters URLs. It also is usually on the same machine that the outgoing firewall is on. Possibly caching so that requests are speeded up, common images, things like that. All the connections that you use on public transport or in cafes are typically a forwarding proxy setup, filtering out requests from addresses that have not yet been paid for example, if you're on a hotel connection. Inside an enterprise, a forwarding proxy will typically be deployed at department level to funnel all traffic for a given department along a specific route. So individual departments might all have their own forwarding proxies in order to bring them all to a common connection point for that department. A typical forwarding proxy setup will look something like this. The access rules are implemented at an application level in the forwarding proxy itself, and they are usually based either at socket or HTTPS HTTP level. On the forward proxy, things like I'm not reading my notes properly. The rules are implemented at a HTTPS and a HTTP level on the proxy itself. IP address and MAC address level would be implemented in the firewall that sits behind it. Proxies make sure that only what you want to go out goes out, and it goes out that direction. Reverse proxy is, as you might expect, works the opposite direction to a forwarding proxy. So in the case of the reverse proxy, it protects the internal clients by hiding their direct IP addresses from an external client connecting. And if your firewall and/or routing rules are set up correctly, will also prevent direct connections, even if the external client does know the server IP addresses. Reverse proxy's application rules would typically be used to filter the inbound client to refuse access to clients that don't have an API key, for example, or from a banned domain name. They would also typically handle the application level routing to internal resources, round robin access to a pool of load balanced servers, for example. Your reverse proxy is pretty much what it says. It's the reverse of the forwarding proxy going out, and the requesting client is terminated at the proxy, just as outgoing traffic in the forward proxy is terminated. So when you have a client that comes into your reverse proxy and makes a request for an internal server, the internal server sees the connection from the reverse proxy, not the connection from the requesting client. The only thing the requesting client sees, or indeed has access to, is the reverse proxy itself. An important job that reverse proxies do is to load balance to internal servers. So if you have a scaled out configuration, for example, you may find that you may have a setup, for example, that's based on the path that is requested. And based on that path, it needs to go to different servers. The UI might be more heavily trafficked than your API backend, for example. So your UI might have 2 or 3 different machines that are configured in a round robin format, but your API might just be a single connection. This is often also how virtual shared hosting providers are set up. Typically, they will have a set number of VMs on a larger VM host and a lightweight proxy sat in front, directing inbound traffic to the specific VM running on the actual host based on the domain name requested. You can spot systems like this a mile away because many of them will have a whole list of very different domain names, all with the same actual IP address. Right. Now, proxies have been around as long as networking, and basically there is a very, very long list of available proxy software. The two big heavyweights that you're most likely to come across if you're setting up proxying are Apache. Apache was the first open source, widely available web server made for Linux and Unix-like systems, and it was originally forked, I believe, from the original HTTPD project used in the earliest Unix systems. And it did start out specifically just as a hypertext server for Tim Berners-Lee's hypertext pages. Apache today, though, has some very serious networking abilities, and it's not just for serving web pages, but for forward and reverse proxy scenarios. Apache's biggest strength is in virtual hosting, and going back to the virtual hosting that I just mentioned a moment ago, you typically find that it's Apache that's sat behind that. Interestingly enough, with Apache, the one configuration that many admins get wrong with Apache is its default forwarding proxy setup. On Pay Internet, for example, you often have a public web portal that's allowed through the proxy to allow you to connect and pay. And if that public portal is running Apache, and if that public portal is set up with the default forwarding configuration for its proxy, you can actually point your own device's proxy settings at the port 80 web endpoint for that and proxy straight through that website and out the other side of the bypassing the paywall. The other big hitter that you're liable to come across in this, and this is the one I use myself personally most of the time, is Nginx. Now, Nginx was created in Russia in the early 2000s, and it was designed from the beginning to be fast, and even today still pushes some very serious benchmarks. At its peak, it was serving up insane counts in the region of millions of connections per minute on a lot of the heavy trafficked Russian social media sites. The difference between Nginx and Apache was it was designed from the outset to provide proxying services. And you tend to find that a lot of .NET developers these days do favor Nginx. Most of the FAQs that are out there, most of the blog posts orientate around Nginx, setting it up as a proxy for .NET deployments. In fact, if you look at the Hain Recruitment's blog, I've just finished a four-part set on creating a Jenkins build server for .NET core projects, and I use Nginx to access the staging deployment of the built project on the build server. So it's very fast and it does the job remarkably well. There are many others, as I say, most notable Light HTTPD, HA proxy, and the one that many of you might be familiar with will be Squid proxy. There's also paid and commercial projects too, if you want ones that come with support. So why do we need a reverse proxy? Well, I think we've pretty much covered that quite adequately so far. Official Microsoft advice, and has been for a while now, is that you do not expose your regular Kestrel-based microservices directly onto a public internet IP. The reasons for this are many, but essentially most of the proxy server software out there that we've already discussed, such as Apache and Nginx, have already gone through the mill. They've been attacked, they've defended themselves against those attacks, they've been around long enough to have built up a battle-hardened stance to current and future threats. So it stands to reason that it's easier to let them take the hammering than your own application. Simplifying the connection is also another good reason. A proxy server, for example, because it terminates the traffic coming in, you can terminate your SSL and or HTTPS sessions at that point. And then the client side inside your proxy only needs to talk to your microservices using regular HTTP. That way you can essentially leave it up to your IT department to deal with the messy stuff surrounding certificates, getting certificates, and the edge computing team to deal with connecting firewalls and all that kind of thing up. I've already mentioned application level routing a couple of times, but there are other things as well. Routing based on host name, geolocation of the source address, load balancing or automatic redirection to a more suitably placed or geographically located web server. Things like AWS have similar setups that mean when you go to a particular instance, it's load balanced to a more suitable geographic region that's closer to where you are. Because it's application level, reverse proxies can also issue web codes. So HTTP, for example, you can manage all of this using 300 series response codes. If you can't find a proxy server, you can issue a 404. If something goes wrong, you can send it elsewhere, or you can just implement something simple like, sorry, the website's under maintenance at the moment, come back later. With a proxy, your web applications just become modules in the larger network, and proxy can be taught pretty much when to use any module over another, right down to inspecting the actual request body contents, and in some cases, intelligent data payload detection can also be used to send data to the correct processor, for example. Rather than just saying JSON and XML, you might have a custom data format, and based on the data format and what the data looks like, that can be sent to a completely different service than your regular JSON and XML. So why Yarp? Well, this is the million-dollar question. Why is Microsoft all of a sudden jumping on a bandwagon that already has plenty of software in this space, and why is it doing so now? Why didn't it do back then? Well, previously, as we've seen, there's plenty of software out there that already fills the gap. The biggest hurdle, I think, however, is configuration. Now, configuration is hard. End of story. I spent nearly 5 years as a senior network engineer for Orange UK before it was bought out. And even in that 5 years, there were many concepts that I just couldn't grasp fully, from routing rules to protocols, physical cabling, air interfaces, and the configuration associated with them all. And I was glad that I had access to Google a lot of the time. Now, let me show you some examples from my own network. I just need to switch away from the slides for a moment. Where's my VMs at? Now, okay. Give me 1 second, folks, because Hyper-V's just decided to die on me. Let's do it this way. Okay. This is actually my live proxy server, so please don't go doing anything silly. But if I log into this and actually go into the Nginx configuration, let's make this a bit bigger. Hopefully that's, I can't change the font size on this with it being a Linux console. So I apologize if it's a little small. Go down here to my Nginx configuration. The first thing you'll notice straight away is the number of configuration files in here. It gets a bit ridiculous manually keeping track of these all the time. But for example, if we open this one here, you can see straight away that this is not something that you want to be dealing with on a daily basis. In the first block, for example, I have the server names that this particular part of the configuration respond to, the host names, and then I pass them through to the internal server here. And you've also got to make sure that you pass headers, things like that. For example, you'll see here I've got a proxy pass header authorization. If your authorization is not passed through, you might present a bearer token within your application, and because it's terminated at the proxy, it may not make it through to your backend services. And I've spent many a day trying to track down errors like this. Your certificate, you know, your certificate configuration as well is not without its problems. I also have configurations set up for just everything that hits a particular domain, you know. So take this for example, that star.digital solutions will hit any host name that approaches it, but it will not take digital solutions on its own. So if you go http digitalsolutions.limited, it won't hit this star.configuration. Yeah, and just little things like that will catch you out all the time. Include files that bring in parts of your certification, you know, and it's this kind of problem that Yarp has been brought in to solve. Also, a lot of developers and customers using .NET Core and .NET microservice-based architectures these days wanted something that their developers understood. They wanted a proxy tool that the developers could deal with both in development on the local machines and the IT teams that were used to proxy servers and network configurations could deal with. A lot of the various teams within Microsoft also wanted access to a supported proxying solution. If any of you watched .NET Conf 2020, you will have seen projects such as Project Tie and Project Steel Toe. Both of these teams needed proxy servers to assist them in developing the projects that they were working on. And from a general software development point of view, many of the pieces of software that I've already shown use static configuration files. They often cannot be programmatically controlled without lots of custom scripting or tooling, which is not much of which is not .NET orientated. Developers wanted a proxy system that the proxying configuration could be stored and retrieved from things like SQL Server and various other application-based things that they were used to working with. And then there's the one.NET vision for Microsoft's single development platform for everything, the common .NET startup class-based programming model, and the .NET command line tooling. So at this point, for the next 15 minutes, I'm going to go through a simple example of Yarp. Now, I was going to try and build it live, but given that we've only got about 20 minutes or so left, I think I'll just take the already running one that I've currently got going. So let's just get rid of those slides a second. Now, I have a small debugging application here. It's just a standard .NET Core application. There's nothing special about it. If you want to grab yourself a copy of this, by the way, it's on my GitHub page. Essentially, it just dumps the headers and the cookies of any request that's made to it. So we're just going to, that's running on port 7000. Okay, so we're just going to minimize that down. And we'll bring the Yarp example up itself. Now, right now, Yarp is only available as a NuGet package. So you can't actually get this as a tool just yet. Microsoft do intend to provide it as a command line tool eventually, and I believe it is going to be made into an official .NET tool as well. Right now, however, if you want to use it, you need to go to our good old friend NuGet, and you need to find and install Microsoft.reverse proxy. Everything is still in preview at the moment, and as we know with preview stuff, it can and it probably will change. Also, you cannot target anything less than .NET Core 3.1, and .NET 5 is actually preferred. So you need to be in pre-release, find that, pull it in via NuGet. Like everything .NET these days, all of your configuration is done in your startup class. This is basically what you need to get your proxy up and running. Do not add MVC or controllers or anything like that. I did actually try that, and it interfered with the routing of the pages, it interfered with things that it shouldn't have interfered with. I don't know if that's by design. I don't know if the team behind it intend to actually make it work with MVC and other things in the application eventually. I would suggest they probably will do. But right now, it's a little bit hit and miss as to how well it does it. The important line is this one. Your configuration comes from get section in the reverse proxy, which is in your standard app settings.json. We'll come back to that in a moment. I must have left that in by mistake, so we'll just comment that out so it doesn't cause us any problems. And then, as with anything else, you just simply map your endpoints to map reverse proxy, and that's it. Essentially, there's nothing more to configuring a reverse proxy server than doing that. You start yourself either a blank project or you start from a web application project. If you want some good startup instructions, then you actually need to go and take a look at this web address. That is the getting started guide. I think I've got that on one of the slides later on as well, so I'll put that back up sort of towards the end. Moving on, all of your configuration comes from your configuration file. Now, that doesn't mean that that's the only place that you can get your configuration from. You can build your configuration in code. You can pull it from somewhere else and provide a proxy setup object. I don't have time to go through that today. That's probably something like a an hour session, something like that. So today, I'm just going to show you a fairly simple setup, and that's this setup here. Reverse proxy configuration needs roots and clusters. Your roots are your rules that you want the proxy server to adhere to. So, for example, here we have match on the path /debug1, and we will send it to this cluster. Your clusters are the actual destinations for those rules. So in this case, you'll see I've got that pointing at my debug proxy, and debug2, I've got it set to go to example.com. If we run this now, yes, you are running. Yep, you've built. There we go. If we run this now, you'll see that I have it set up just to go to its own console mode on the standard 5000 port. And if we just grab a browser here and go to localhost 5000, you'll see that we'll get a 404. And that's simply because there are no rules in your routing configuration to send that anywhere. If we, however, go to debug1, you'll see that that sends us directly to my little demo one that we have running. And interestingly, you will notice that the URL doesn't change. This is how you know that your connection's been terminated, because that connection remains the same. Unlike rewrite rules, things like that, where you can change the URL, you typically can't with a reverse proxy. So it secures your back-end services in that respect as well, because nobody knows what your back-end services are listening on. If I go to debug2, you'll see again it takes us to example.com, but that doesn't change. As far as the person viewing this site goes, all they can see is the address that they've typed into their address bar. Right, we'll kill that for the moment. Now, paths are not the only things you can match on. For example, you might want to use your proxy configuration in a more, what's the word I'm looking for? In a more normal way, whereby every request that hits that endpoint gets sent to some other particular service. And for that, we use a catch-all path. And the catch-all path, very simply, looks like this. ** catch -all in curly parentheses. So what will happen now when I run that, instead of getting the 404, yep, there we go. Instead of getting the 404, when I go to the root of the site, everything should just end up. Okay. Right, I'm not going to try and track that down. For some reason, there's a gremlin there somewhere. The upstream connection's been refused. So basically what's happened there is not the proxy server refusing the connection, but the back end. The two errors you're likely to see are that and gateway, I think it's a code 502, upstream gateway not responding. We've got 10 minutes left, so I'll move on with this rather than try and track that one down. That's your catch-all path. If you want everything within your root configuration to be redirected, no matter what the URL is, then that's what you use. And of course, you don't only have to match on paths. You can match on headers too. So for example, if you wanted to match a host name, then you can actually add something in like this alongside your path. So if we change that back to our catch-all, and then we add this bit in here, we can say, right, we are looking for the host name header, and we are looking specifically for a host name of that service.mydomain.com. And what will happen there is the host name that's provided by the browser accessing that surface will be then checked via your proxy configuration, and if there is a match, we'll send it to the cluster that's associated with it. Because it's a catch-all, then that route there will never get matched on anything. The other thing you do need to, the thing you do need to be careful with regards to the configuration of this is that order is important, by the way. I probably should have mentioned that before when I first put this configuration up, but order is important. A catch-all put in front of any other rule like that will always match, nothing else will match. So always put your catch-alls at the end as a way to mop up anything that's not matched more specifically. Of course, it doesn't have to be a host name, and you can actually look for multiple strings as well. So we could say API key. Okay. We could have a header in like that, and this could be generated from our clients because we're in charge of the client app that's connecting to this. We could make sure that the API key is in there, and then we could do something like this: ABC 1 2 3 and DEF 4 5 6. In this case here, that header will match either of those values. If API key exists and those keys are in there, either of those keys are in there, then that will be redirected to 7000. Again, catch all. You can also specify header prefixes. So if we change this from exact to header prefix, for example, any value in that particular web page header that starts with that will now be matched with header prefix. The third one is exists, and exists is exactly as the name suggests. Exists will match if that key exists in the headers, not necessarily whether it has a value or not. So even if it's there but doesn't have a value, that rule will still match. And authentication as well. You can terminate the authentication at the proxy server rather than at your microservices that are sat behind it. I don't have an example of that, but if I bring up the authentication page from the official docs, you can see here that they have a custom sort of policy there for authentication and authorization, and then that's plumbed into your startup in the same manner, except you use options.add policy to tie it to a policy, and that policy can be provided using standard Microsoft APIs, identity framework, identity server, JSON tokens, JSON web tokens, anything like that, roles, and all sorts of other stuff. Right, so that's about all I've got for the technical demos. So let's just switch back to the slides. Right. So that's probably about all I can fit into the 45 minutes or so that we have today. Quick summary: proxies help with network security in lots of different ways. Unless you've done a lot of sysops or system admin work, configuration of many proxy systems requires learning a lot of extra stuff that you as a developer may not have time or any interest in doing. And Microsoft has looked at this problem. It's listened to the developers, it's listened to its clients, it's listened to its internal teams, and Yarp is its solution. Now, how will it turn out in the long run? We don't know. It's still very, very early days, but already what we have to start experimenting with is looking very, very promising indeed. And it's going to replace a lot of this messy configuration system that many people have in the production systems. In fact, I would probably go so far as to say in the next 6 months or so, we're probably going to see a number of new web-based tools that can be deployed straight onto a virtual server and then configured from an admin panel or directly from a database, something like that. And that is going to make a lot of this work, particularly in DevOps, a heck of a lot simpler. If you want to chase up on this and go and learn some more, the official blog announcement is at this address here. Yarp GitHub Docs, which is the getting started that I showed you before, is here. And dev2.net on all your usual places, YouTube, MSDN Channel 9. There is an episode on Yarp, and it is well worth watching. It's only about 10 to 15 minutes long, but it gives you a really good idea of the direction that they're heading in. I'll leave that slide up for the moment, and we'll switch back here and we'll see if we have any questions. You'll have to bear with me a moment. I'm a little bit of a virgin with Teams. Oh, my webcam video's frozen. Okay, well, that's fine, I believe, as long as my presentation hadn't. Q&A. Has the video frozen? Oh, okay. Feel free to jump in here, Liberty.
There are 3 in the publish section.
3 in the publish. Ah, there we go. I found them. I found them. Okay. Many people will know something of load balancers and gateways from Azure and AWS. Yes, many people will know, but that kind of highlights the point I was making about configuration being hard, because many people will look at the AWS control panel and it's all web-based. You click a few buttons, you type a few things in, and magic happens. You know, I'm specifically referring to setting up the routing manually, and people do it. People do set up their own proxy servers on AWS, bypassing the AWS controls. It's messy. It's very messy. It's not very hard to forward HTTP requests in C# code, but hard to make it scale. Yarp promises performance levels comparable to Nginx, which is awesome. Okay. Not particularly sure if that's a question, Anthony, but thank you for the point. Yes, David Fowler has done a lot of work on the project. Has Yarp got hooks for custom code and plugins yet? I believe it has. Everything that you need to know is on the GitHub docs. The data structures, I believe, are also there somewhere. Let me see. No. Let me open. Let me just open the docs, and this is what I get for closing the browser down that I was using. The data structures are in here somewhere. Yeah, so for example, you can see here, we can create these data objects in code, and we can create the client in code, and we can do everything manually without ever even touching the configuration in the system. Same with transforms. We can actually transform incoming headers, incoming custom headers, incoming normal headers, incoming payloads. We can do that both in the configuration and in the code as well. So yeah, I can't actually find the links. There is a link somewhere in the documentation site that shows you all of the different data structures and that you might want to take a look at. And I think that's it. So David Fowler, Anthony. So are there any more questions out there? Yes, no? Yes, it appears that my video camera did freeze. Did my presentation freeze, by the way?
Nope, that was all good.
No, oh, thank you. Right, well, in that case, we're just 1 minute over. I don't think there's any more questions, so I think we'll call it a wrap there. Don't forget, please, I'll put the slide up again. Please do go and contribute to this. They are a charity. They have some pretty awesome kit there as well, including one of my favorite ever machines, the one that I learned on as a kid, the BBC Model B Micro. They do regular hackathons and all sorts of things, and it really is a good day out, even just to go and see it. They're always fundraising. Do what you can to help them, and help them help us to keep on putting on events like this as well. And on that note, go ahead and hack the planet. See ya.